Hi, today we're going to do some more trig equations, and this time we're going to put it together with the section we've just completed on compound and double angles. The first equation we're going to do is cos of 2x is equal to cos x plus 2. Now remember, when it comes to cos of 2x, we have three possibilities. Either cos squared x minus sine squared x, 2 cos squared x minus 1, or 1 minus 2 sine squared x. So we have to pick the one that is going to give us a quadratic equation with a middle term of cos x. All right, this ties in with the last video. So here I'm going to write 2 cos squared x minus 1 is equal to cos x plus 2. That then becomes a quadratic equation. 2 cos squared x minus cos x minus 1 minus 2 is minus 3 is equal to 0. When I factorize that quadratic equation, I get 2 cos x I want to land up with a middle term of minus 1, so the 3 is going to go there, the 1 is going to go there. I want to get a minus 3 cos x and a plus 2 cos x, and so those are my two brackets. Immediately I have a product equals 0. All I do is I can put each bracket equal to 0. So in this case over here, I'm going to land up with cos of x is equal to 3 over 2. Over here, I'm going to get that cos of x is equal to negative 1. The moment cos is bigger than 1, when you try and arc cos 3 over 2, you are going to find that there is no solution. Okay, the maximum value that cos x can have is 1. Arc cos of minus 1 means that you're going to get plus or minus 180, which is exactly the same thing. Okay, positive 180 and minus 180 are in exactly the same place, plus k 360, where k is an element of the set of integers. All right, the double angle here that we're going to use is sine of 2x. Okay, expand that and you get 4 cos squared x plus 2 sine x cos x minus 1 is equal to 0. Now, as we saw yesterday, the moment you have a potential middle term of a quadratic of sine x cos x, you need to have a cos squared, a sine squared, and no constant term. So I'm going to replace that number 1. I'm going to write 4 cos squared x plus 2 sine x cos x minus, remember to substitute in a bracket, the number 1 is sine squared x plus cos squared x. Simplifying, 4 cos squared x minus cos squared x is going to be 3 cos squared x plus 2 sine x cos x minus sine squared x is equal to 0. Sorry, I left out the equal 0 over there. I now need to factorize this. The first bracket is 3 cos x, the sine x at the back, cos x, the sine x equals 0. I want to land up with a plus 3 cos x sine x and a minus sine x cos x to get that positive 2 sine x cos x as my middle term. The moment a product is equal to 0, I can say that 3 cos x is equal to sin x, and cos x is equal to minus sin x. When sine equals cos, remember I cannot use the Cocoa rule here because there's a 3 in front of that cos x, but what I can do is divide both sides of that equation by cos x and land up with 3 is equal to tan x. Sin x divided by cos x gives me that tan x. Okay, then we need to arctan 3. And arctan of 3 gives us an x value of 71,57, the general solution for tan plus k 180. Over here, I'm going to divide both sides by cos. Okay, so here I'm going to get that 1 is equal to minus tan x. I far prefer to write that as minus 1 is equal to tan x. When I take arctan of minus 1, I land up with minus 45 degrees plus k 180. And again, k is an element of the set of integers. This sum over here, again, I have to make a decision out of which of the 3 I'm going to use for cos of 2x, and because in this case the potential middle term of my quadratic is going to be sin x, I am going to choose to write cos of 2x as 1 minus 2 sine squared x. That is now a quadratic. Everything on one side equals 0, so I get 2 sine squared x plus sine x, and in this case 1 minus 1, the constant disappears. My factorization here, well, it's not a trinomial, but I do have a common factor of sine x. My bracket becomes 2 sine x plus 1. So this means that sine x is equal to 0, or sine x is equal to minus a half. Arc sine of 0, sine of what is equal to 0 is 0. So on this side, I get that x is equal to 0 plus k 360, or 180 minus 0 plus k 360. On this side, arc sine of minus a half gives me minus 30 plus k 360, or I get 180 minus minus 30, which is going to be 210, plus k 360, and again k is an element of the set of integers. Now, all 3 of those examples involved our double angle formula. Now I'm going to show you an example where we can in fact use our compound angle formula. You've got an x and you've got a 20 degrees. Notice cos plus sine. I can combine that to become cos of x minus 20. So be on the lookout for maybe simplifying a real mess just using your compound angle formula. At this point, I can now use my Cocoa rule. So I'm going to say cos of x minus 20 is equal to cos of 40. So x minus 20 is equal to plus minus 40 plus k 360. Remember, you're always going to split that up. So you get x minus 20 is equal to positive 40 plus k 360, or x minus 20 is equal to minus 40 plus k 360. Taking that across, x will equal 40 plus 20 plus k 360. Taking that across, Minus 40 plus 20 is minus 20 plus k 360, where k is an element of integers again. So now we've really finished all the theory in terms of solving different kinds of trig equations, and we're now going to start working through exercise 5.9. Please will you do 1D, 1G, 2A, 2B, 3A and B, and 5A and B. Thanks.